Okay, so what we're going to do today is have a look at the idea of units. So when we do any engineering or physics, we end up measuring a lot of things. And whenever you measure something, you want to give the unit that it's measured in. So when you were doing your pendulum thing yesterday, and I came to you and said, how long is your string? None of you said 55. You all said 55 centimetres, or you weren't making me guess whether you were using miles or kilometres or whatever it was. You actually all told me. In the end, how long a piece, question for everyone, how long a piece of string do you need to make a 1 second pendulum? And the answer is 1 metre. 1 metre, isn't it? Yeah, so you give me a unit of metre. So whenever we measure things, you want to have a unit on them. So what we're going to do today is have a look at what units we're going to use for measuring a whole lot of things. So I've got 2 boards, which is awesome, because I usually have 2, and then we have to write real small, so I'll try for 2. So on the board, I'm going to write, no, I'm going to, spelt the first word wrong. Third letter in, and I made a spelling mistake already. Brilliant. Okay, so we're going to have the quantities that we're going to measure, so the things that you'd want to be able to measure, and then we're going to have the unit that you'd measure them in, and the symbol for that unit. So we're just going to make a big table with a whole lot of things that we want to be able to measure, and a symbol, and a wee bit of space so I can write extra things and maybe tell you a story. Emma's looking confused. I'm going to use that whiteboard as well. Oh, it's a better what we've got dodgy whiteboard marker. All right, cool. And on this board, because I reckon there's going to be a lot of things, I'm going to do exactly this. Oh, look at this, a much better whiteboard marker. That was the problem, I can spell with this good board. So again, the quantities you want to measure, the units we're going to measure them in, and the symbol, because I reckon that there's going to be more than enough to fill one board of types of things that you want to measure. Okay, so this is really over to you. I'm just going to write things on the board and maybe fill in some gaps. So you're going to tell me what things you want to measure and what units you want to measure them in, and then I'm going to put them on the board and ask some questions around trying to help you clarify your thinking a bit. Like we talked about yesterday, weird ideas with disciplined thinking. So this is about trying to tighten your thinking up a bit on some of these things. Okay, so what's one thing you might want to measure? Length or distance. Yep, okay. So length, distance, brilliant. And the unit for length or distance that we're going to use is meters. Okay, right. This is really good. So the base unit is a metre, which is an M. And we've already started to talk about centimetres, millimetres, kilometres. There might be some other types of metres as well that we may have to think about. So we need to get an understanding at some stage what all these silly letters out the front mean. What does a C and an M and a K mean? Okay, so we'll talk about that later on today. Once we've covered the units, we'll talk about that as well. Okay, so here's a really interesting question for you. What is a metre? 100 centimetres. Dylan has given us the ultimate answer that everybody always gives, 100 centimetres. So my next question, Dylan, or anybody, is what's a centimetre? 10 millimetres. Awesome. Okay, so what's the next question I'm going to ask? What is a millimetre? Exactly, the man's onto it. 1,000 micrometres. It's 1,000 micrometres, correct. So what's the next question I'm going to ask? What is a micrometre? Okay, I don't know. It's 1,000 nanometres. Okay, the man's onto it. Well done, Meredith. So there's 1,000 nanometres. And the next question I'm going to ask is, what is a nanometre? Okay, you can keep on going. You can go to femtometres and picometres if you want to, but you still haven't answered the question. Okay? It's like me saying to you, what is a student? And someone saying it's 1/20th of a class. What is a class? It's 1/20th of all the things you run in Dunedin. It doesn't help you. It's just the same thing in different sizes. So what is a metre? Really hard question. Yeah? What is a metre? It's a yay much. That's yeah, that's pretty good, isn't it? Yeah, this will do. Or one good. That's a metre. Yeah. Okay. Easy. Okay. So we need a better way. We actually all need to agree what a metre is. Okay? And this is a historical problem. this is something which caused some problems in history. So there was a time back before the system we use now, which was called the SI system. I can just about reach the top of this board. I hope you've got this on the video, that it reaches up this way. So the SI system of units, which stands for Système International, which is French for System International. I'm pretty good at French. That's about the limit of my French, okay? So we have this system of units, and one of them is a metre. Okay? The metre was, before that, was the yard, was the standard unit. It's about yay much, yep, as it was a yard. And for a while, it was the length from the fingertips to the nose on the King of England. Okay? So that was a yard. Problem is with that is, what's the big problem with that? New King, Henry VIII. So yard goes from, yeah, so suddenly, and obviously all the people in the shops who were measuring yards of material didn't get Henry to come along and go, all right, can I measure to your nose? Yes, they'd all agreed what a yard was anyway. It was sort of an official measure. It's like, we have Queen's birthday whenever we have Queen's birthday, April, May sometime, and our real birthday is a completely different day. So it's kind of like the King's yard and the real yard. Yeah. So they had to have some way of measuring what a yard was. And then the French decided that they were going to have this system where everything was going to be nicely uniform and everyone was going to agree what it was. And they decided that a metre was 1/10,000th of the distance from the equator to the North Pole. Yep. So that's what a metre is, or was going to be, 1/10,000th of the distance from the equator to the North Pole. It drove Napoleon to conquer, but it was around the time that Napoleon was doing things. So, yeah, exactly, the metric system. Yeah. So they set out to survey across France to find out how far it was. They knew roughly what it was, but they wanted to have it exact. So they set out to survey across France. So they had these guys with surveying gear, which you're going to use next week. We're going to get you set up with a whole lot of surveying gear, maybe the week after. So they had these guys with surveying gear trying to survey their way across France to find out exactly how big it was. And the way you survey is you go up the top of the nearest tower, church tower or something, you spot a landmark as far away as you can, you get your telescope, you view it, you figure out what angle it is, you go to another tower, you look over there and you do a whole lot of measurements and you can figure out exactly how far things are apart. Problem was, this happened while it was happening. It took about 4 or 5 years to go right across France. It was the French Revolution came along. And these guys that were kind of from the aristocratic class, so the guys who were interested in science and stuff, they didn't have to work in the fields, they had time to do this sort of thing, were busy going up church towers with surveying and telescopes and things. And the revolutionaries were sure that it was a military manoeuvre. They're up there spying on what's happening on the revolution. So quite a few of them ended up in trouble with the revolutionaries and ended up, a couple got killed because they were trying to survey across France. So in the end, they figured out how far it was across France and did the calculations for the 10,000th of the distance to the North Pole, and that was officially became a metre. The problem with that, again, is if you want to measure out your piece of material or you measure out your bit of wood that you're going to buy or sell, you go, I want 1 metre worth. You're not going to take your bit of wood and lie it down 10,000 times and go, oh, damn, it's a bit short of the North Pole. I better get a longer piece. Yeah, it's not the way you do it. So you need something you can use day to day. Yeah. So what they did was they just got a piece of metal, an aluminium bar, and they did all the calculations. And this is 1 metre. And it lived in a box in Paris, and that was 1 metre. Yep, and it's still there. And they made copies of it that went out to people to be able to do their own measurements. And now you can buy a metre tape or whatever, and it's just it's a copy of the original, the real metre.
Yeah, I was actually watching a YouTube video where they made the world's most roundest ball.
Yep.
That's going to be the new way of measuring.
It'll be the practical way. So nowadays it's defined differently. So for a while it was the length of the thing in the box in Paris was it. That was a metre. Okay. And if you wanted to check out if your metre was real, you took it to the box in Paris and compared it. They've since got other ways of doing it. So the way that one of the official definition these days is it's a little bit of atomic physics. Are you ready? It's going to just do a little bit of atomic physics here for a moment. It's not too hard. You'll manage it. So in an atom, you have a nucleus, which is made up of protons and neutrons. And then around that, you have electrons. Yep. Okay. And if you have an electron in an atom sitting there minding its own business, it's just quite happy. Yep. And all of a sudden you give it a bit of an electric shock. So you bzzzt, what happens to the electron? Yeah, and it jumps. So it leaves that spot and it jumps up onto the spot up here. Yeah, and then if you leave it alone for a while, it goes, oh, and it goes back. So it goes back down there. And when it goes back, it gives out some energy because it's got this extra energy from being jumped. So it's got extra energy up here. It gives that back up, and that extra energy comes out as light. Okay? And if you're doing the same atom every time, the amount it falls back is exactly the same every time. So the type of light that comes out is exactly the same every time. This is how streetlights work. So there's different colour streetlights. So the yellow ones are sodium atoms doing this. The white ones, I think, are magnesium. The reddy colour ones are strontium. Okay? So it's just a different amount that it's dropping means you get different types of light coming off it. And the different types of light are just because this wavelength is slightly different for each colour. Okay? So the way a meter is now defined as, a meter is a whole bunch of these waves on a jump in a particular atom. I think it's a cesium atom, I can't remember the details. Okay? So that's the official definition of a meter.
Oh, really?
Yeah. Yep. So and it's a lot of these wavelengths because these things are in blimmin', there's millions of them in a meter. Yep. So basically, if you want to get an official measure of a meter now, you've got to fire up your cesium atom, give it a kick, wait for the thing to drop, see the light that comes off, measure it, count a million of these things, and that's a meter. Okay? Which again, you can't do practically. So we sell tape measures and things that do the job for us. But that's the official definition of a meter. Right. What is a meter? Oh, it's about that much. It is officially, I can't remember the number, but a certain number of wavelengths of light emitted when an electron transitions between two particular states of a particular atom is the official definition. Yeah. But like for all practical purposes, it's whatever it says on your tape measure. Yeah. So I'm not going to give you an exam question on what is the official definition of light of a meter. But it's that complicated. You know, trying to answer a real simple question of what's a meter, you have to understand some atomic physics. Yeah. So it's just giving you an appreciation of the level of depth. Okay? Cool. So we can measure a meter. Well done. At this rate, we should be finished about 7 o'clock tomorrow afternoon. Okay. So what else do you want to measure other than length? You're just doing two different things. Which one do you want to do? Weight. Okay, radio. Weight is good. We'll do weight. Happy with weight? And what do you think the unit for weight is? Marilyn is very, very dubious now because I said there were two different things going on. Anybody else for the unit of weight? Mass. Okay, so mass is the other thing we can measure. Well done, James. So mass, I'll put this on this board. So mass is something different from weight. So weight and mass are two different concepts. And I'm going to explain the difference, but does anyone have any idea what the units for either of them might be? One of them.
One's volume, the other one is.
This one's to do with kilograms. Volume, something you want to hold onto your hat for next to when we start the next. Once you finish these two and I say what else, then we'll volume out. Okay, so this one, the basic unit is the kilogram, which is a wee bit weird in that it's got the K in the basic unit. Everything else has the funny letters in the bonus ones, whereas the mass has the kilogram. Okay, brilliant. Okay, we're on a roll. So what's the difference between mass and weight? That's exactly what it's got to do with gravity. My mass, about 90 kilograms. I don't know how much porridge I had this morning, but somewhere between 90 and 92 usually. So we'll say 90, I'll be generous. So my mass is about 90 kilograms. If I go to the moon, my mass, 90 kilograms. If I go into outer space, my mass, 90 kilograms. Okay? So mass has nothing to do with where you are or what gravity is going on. It's just the amount of stuff that you've got. Okay, so mass, kilograms, completely independent of where you are. Okay, weight, on the other hand, is actually an example of a force. Okay? And weight is how hard I push down on the ground. Okay, so on Earth, I push down a lot harder than if I'm on the moon. And if I'm in space, I don't push down at all. So in space, I'd have a mass of 90 kilograms, but no weight. Okay? Hence the phrase like weightless. Okay? If I'm on the moon, I have about 1/6 of the weight I have on Earth. Okay? So on the moon, my mass is still 90 kilograms, but my weight has dropped off. Okay? So the question is, what is my weight on Earth? So if you say to me, how much do I weigh? I'm going to tell you, about 883 newtons, because I'm a physicist. And I will answer these questions precisely, especially in a physics class. Yep, okay? So the question is, where did I come up with this 883? You know, obviously, I know my weight in newtons. Okay, and the answer is that weight is whatever your mass is times gravity. Okay? And on Earth, gravity is about 9.81. It changes slightly depending on exactly where you are, but 10 is pretty close. If you're doing ballpark calculations, 10 is good. Yep, pretty damn close to 10. But we're going to go, we'll use 9.81 for calculations. So you get into the habit of doing that because that's standard engineering practice. But if you're just doing a sort of a rough calculation, 10 is pretty good. Okay, so me, weight of Richard is my mass, going with 90, times the 9.81 equals, I think that's the 883 that I was spouting. Someone will do it. Who's got a calculator? Was it? Let's say 81 and 70, 88. Yeah, no, I'm pretty happy with that, 883. Maybe 882.9 or something, if someone's done the calculation. Yep. Okay, so my weight is 883, something. So we need a unit here for this, newtons. So any force is measured in newtons. And the symbol for that is capital N. So I'm 883 newtons as my weight. Okay? So if I went to the moon, my mass would still be 90 kilograms, but my weight would be somewhere down about 150 newtons. Okay, so quite an important difference between mass and weight. Make sense? Yeah. So weight is a force measured in newtons, which is different from a mass. Okay. Just ask questions as we go. You don't have to wait for me to take a breath, otherwise you'll be waiting for a long time. So just keep asking questions. Yeah. Cool. Rightio. I'll leave that there in the meantime, but we might need to rub that out to make some more space in a wee while. What else do we want to measure? Volume. Volume. She said volume before, so we'll go back to volume. Okay, so what are we going to measure volume in? Okay, so litres. We have a couple of acceptable units here. Litres is definitely one. Yeah, but then that's all that milli and centis and stuff. You sure? Yeah, okay. Okay. Litres are kind of small. If you're doing engineering, litres, you're going to pour concrete. You don't want to say, I'm going to pour this much. I don't want to pour this many litres of concrete. You're not going to measure your concrete in your building in litres. Cubic metres. Cubic metres is absolutely what you want to be looking at. So litres is a capital L, and cubic metres looks like that, metres cubed. Do you happen to know the relationship between those two, Roland? Do you know how many litres there are in a cubic metre?
No.
Anyone? 1,000? Well done. Okay, so 1 cubic metre is 1,000 litres. and yeah, that's something you need to know. And at the moment, you think of volume in litres, but very quickly you'll stop thinking of volume in litres and you'll start thinking like engineers, and you'll start thinking in cubic metres. Okay? So if I say to you, how much water is flowing in the Leith at the moment, and when you walk across that bridge, how much water is going underneath it, the unit you'll be thinking of is cumecs, cubic metres per second. And the answer is about, did it rain last night? Probably about half a cubic metre per second. So every second there's about half a cubic metre goes under that bridge, which is 500 litres. But if you go down to Balclutha and you drive across the Clutha and you go, how much water is going under here? Yeah, no one really wants to know that it's 500,000 litres per second. It's 500 cubics. It's typical. Unless it's flooded, in which case it's 5,000. Goes up quite big, that river. But that's an engineering thing. If any of you do civil engineering and water and waste, you'll a whole lot of stuff with how much water is flowing in places. Okay, cool. So volume's an important thing you want to measure.